Welcome to Vector Algebra. Vector product or cross product. Let's consider two vectors in this plane, vector A and vector B, acting at an angle theta between them. Now, what is the cross product, vector product of these two vectors? Vector product is a vector. The result will also be a vector. In fact, that vector will be going in the direction perpendicular to the plane containing A and B. So the A cross B will go in this direction, perpendicular to the plane. Now, how long, how big, what will be the magnitude? To get the magnitude of that cross product, we need to multiply the vector A magnitude and magnitude of this vector and sine of the angle between them. That is why the definition read like this. A cross B is equal to, the cross product is equal to magnitude of A into magnitude of B into sine theta into n cap. What is this n cap? N cap is the unit vector in that direction, in the direction perpendicular to the plane. Now, this n cap, if you multiply by a magnitude, it will be long enough, this much long. How much? The magnitude is magnitude of A into magnitude of B into sine theta. So the A cross B vector will be in the direction of this n cap, the perpendicular to the plane containing A and B, having the length this much. Magnitude of A, magnitude of B sine theta. This portion is the magnitude and the n cap gives the direction. Now let's see what is B cross A. B cross A should be magnitude of B into magnitude of A into sine of the angle in the reverse direction, so sine minus theta. As we know, sine minus theta is minus sine theta. So we can say B cross A will be minus of B magnitude of B into magnitude of A into sine theta. So that gives a relation between these two cross products. A cross B and B cross A will be equal in magnitude but opposite direction. So if A cross B goes this way, B cross A will go its opposite direction like this. The length will be the same. If A cross B is this big, B cross A is this big, but in the opposite direction. So A cross B is equal to minus B cross A. Now, as I mentioned already, magnitude of this A cross B is magnitude of A into magnitude of B into sine theta, the length from here to here. This n cap is here only to mention in which direction it should go. Now let's see how we do the vector product when the vectors are given in the components form. To do that, we have to first of all do the cross product of the unit vectors taken along the x, y and z axis, I vector, j vector and k vector, the three unit vectors taken along x axis, y axis and z axis. And what is I cross j? I cross j, as we know, I is unit vector along x axis, j is unit vector along y axis. So I cross A will be magnitude of I into magnitude of j into sine of angle between I and j, that is 90 degree, that is pi by 2, into the unit vector perpendicular to I and j will be the k vector. So I cross j is magnitude of I into magnitude of j into sine pi by 2 into k vector. That is equal to 1 into 1 into 1 into k cap, that is k cap. So we got a new result. I cross j is k cap. Now, as we have already mentioned, A cross B and B cross A are of opposite sign. So j cross I will be minus k vector. Similarly, let's have now j cap cross k cap. Cap because they are unit vectors. Magnitude of j, magnitude of k into sine pi by 2. Once more pi by 2. Why? Because angle between j and k will also be pi by 2. Into I vector. Why is it I vector now? Because j and k lie in the YZ plane. So the perpendicular direction is in the x direction. So I cap. Hence, j cross k is equal to I cap. Magnitude of j and magnitude of k 1 1 each. Sin pi by 2 is 1. So it is equal to I cap. By applying this property, we can say k cross j is minus I cap. Next, k cross I in a very similar way is equal to j cap. And I cross k is minus j cap. Now we need to remember these 6 products. How to remember? We will go in the cyclic form. If we take the cycle in the form ijk, the usual alphabetic order, then we can say I cross j is k cross I is j cross I is j cross k is I. So if you're taking in this direction, the third element will be the result. Whereas if you take it in the reverse order, j, I, k, then the vectors formed will be negative. That is, j cross I is minus k, I cross k is minus j, k cross j is minus I. So these 6 results are ready now. We need to know what is I cross I also. I cross I. I cross I is magnitude of I into magnitude of I into sine 0. 0 because angle between I and I is 0. Sine 0 is 0, which makes the whole thing 0. 0 vector. So I cross I is 0, j cross j is 0, k cross k is 0 for same reason. Hence we have these 9 results ready. To find out the product of two vectors when they are given in components form. A cross B, the definition is this. But here A and B are now given in their components form. A vector is A1 I cap plus A2 j cap plus A3 k cap. B vector is B1 I cap plus B2 j cap plus B3 k cap. Now if you want to find out the cross product has to be done between these two vectors. First vector is this, second vector is this. Now if you distribute the terms, we will have 3 3s are 9 terms. What are they? A1 I cap cross B1 I cap, which is A1 B1 I cross I. But we know I cross I is 0. So the first term is 0. Now A1 B2 I cross J, I and J, I cross J is K. So A1 B2 I cross J. In the next step we will write it is A1 B2 K vector, etc. Distribute all 9 terms. Now start writing the values. A1 B1 I cross I is 0. A1 B2 I cross J is A1 B2 K. Then next is A2 B1. A2 B1 J cross I. J cross I is in the reverse direction, so it will be minus K, etc. If you go on writing and collecting the like terms, you have I terms, 2 of them. A2 B3 minus A3 B2. I terms. This is one I term, this is one I term. Taken common. Similarly here this is a j term and this is a j term. Collect together. Then we have it. This could be obtained just by expanding this determinant also. In fact, cross product is the step. But just to remember, we are going to write this long expression, this algebraic expression as a value of a determinant. As you can see, if you expand this determinant, it will end up in this expansion. I into A2 B3 minus A3 B2. Here it is. When you open the determinant, we write minus j into. Then it is A1 B3 minus B1 A3. But here it is written reverse. That's why here plus is written. Similarly, the third term. So when A and B are given in the components form, the cross product can be obtained by just expanding this determinant. First row is ijk unit vectors. Second and third row are the coefficients of ijk from these two vectors, a1, a2, a3 and b1, b2, b3. Here it is. Once you expand, you get the required result. Here there is a triangle ABC. It's a scalene triangle. Now I'm drawing an altitude from C perpendicular to the side BC. And the altitude length is h. Now from this triangle, right triangle, with an angle theta here, we may write h is equal to AC sin theta. H upon AC is equal to sin theta. Therefore, h is equal to AC sin theta. Now, if you want to find the area of this triangle, we could have used half into base into height, half into AB into h, and I'm replacing this h as AC sin theta. So half AB into AC sin theta. This could be used as a formula to calculate the area of a triangle ABC using two sides AB and AC and the angle between them. Half into AB into AC into sin theta. Let's see its use in vector algebra. Here I am taking two vectors, vector A and vector B, acting at an angle theta. Now, had we taken its cross product, A cross B, it is defined as magnitude of A into magnitude of B into sin theta into n cap. Magnitude of A, magnitude of B into sin theta into n cap is the A cross B vector. If this is A cross B vector, what is the magnitude of A cross B? Magnitude is only this much portion without this n cap. Magnitude of A, magnitude of B sin theta. Now, come to this diagram and consider a triangle having vector A and vector B as two sides. This is a triangle. Now, as we have already derived a formula to find the area of a triangle, half into product of two sides into sine of the angle between them, half into the product of two sides. The two sides are represented by vector A and vector B. So their length will be magnitude of A and magnitude of B. That is what vector AB and vector AC. So area of this triangle is half into vector AB into AC into sin theta, where AB is nothing but magnitude of B vector, AC is nothing but magnitude of A vector. So we have half into magnitude of A, magnitude of B sin theta, vector A and vector B used. This part is nothing but the magnitude of A cross B vector. So we can write it as area of the triangle is half of magnitude of A cross B vector. One point you may notice here. A cross B is a vector. So it has a length. Say for example, this vector has 10 units length. That 10 is obtained by multiplying these three numbers. So 10 unit long is a vector. But that 10 units long vector magnitude is 10. Its half, which is 5. 5 square units will be the area of this triangle. That is a relation. Area of this triangle, area is not a length. But notice that whatever the length of the vector A cross B, its half square units will be the area formed over here using the same two vectors A and B as two sides of the triangle. Now, let's extend it to a parallelogram. This is a parallelogram whose adjacent sides are vector A and vector B. Then this BC is the diagonal of this parallelogram. As we know, the diagonal of a parallelogram divide the whole parallelogram into two triangles, two congruent triangles, because of which the area of each triangle will be equal. So, double of the area of this triangle will be the area of the parallelogram. Hence, we can go like this. Area of the parallelogram will be double of this. Double of this means magnitude of A cross B. Here we have two formulae now ready. To find the area of a triangle whose sides are represented by two vectors, vector A and vector B, we can go for finding half of magnitude of A cross B. Then remember to write square units as the unit because it's area. And area of the parallelogram will be double of this triangle's area. Or directly we can say magnitude of A cross B.